So for today's session, we'll be doing indefinite integrals. So last time we had definite integrals. That's an integral where we have the lower limits and the upper limits of integration, etc. And then after that, we discuss what we call the antiderivatives. Okay, and now we will have indefinite integrals, and we will see that all these three topics are related to each other. So let us recall the fundamental theorem calculus 1. Let's start with um, here. If f is continuous, or if small f is continuous on the closed interval AB, then the derivative of the integral of f of t dt from a to x, this is simply f of x for all x inside the interval AB. So take note in here, the continuity of f is on this closed interval. Here, if we are differentiating, we just have the open interval. Take note that when we do derivatives, we look at the limits from the left and from the right. Okay? But if you have a closed interval, for example, at this point A, you cannot have limits from the left. You have limits from the right of A, but from the left of A, you don't have. So that's the reason why we cannot define the derivative at the end points of interval. Okay? So we just consider the open interval here. Okay? And then the second fundamental theorem of calculus. So if capital F is an antiderivative of small f on the closed interval AB, then the definite integral of f of x dx from a to b, this is just capital F of b minus capital F of a. Okay? And if you combine these two statements here, um, you would observe that the integral and differentiation are inverse processes of each other. Okay? So one of them cancels what the other does. So if you have the integral here, you get the derivative here. Um, you'll get back the function, the integrand in here. And in here, if you look at this, okay, so again, you can rewrite this as the integral or from a to b of capital F prime of x dx. Okay, and here you will have um, f of x evaluated from a to b. Okay, and this is just this expression here. Okay, now when I say the derivative of the integral is the function, or the integral of the derivative is the function, it's loosely explained in a sense that, of course, you have those conditions. Okay, of course, if, for example, here the function, this is your function here, this is the uh, this guy here, this part here, this is your function capital F of x. So if you get the derivative of this, okay, you will have this small f of x. So the derivative of this will be equal to small f of x. Okay? Whereas in here, you have your definite integral, and um, this is the capital F prime of x. If you integrate that, it seems that you are using capital F of x. Okay? Take note. Take note that, okay, so let me just give this as a warning. You have here the derivative with respect to x of a definite integral from a to b of f of t dt. Okay? So take note, you are differentiating with respect to x and you don't see any x in here. Okay? Recall that this guy here, okay, this is a number. This is a number if it exists. Okay? Number if it exists. Meaning if you have the definite integral, you get the limit of the Riemann sum and you get a number. Okay? Which means the derivative with respect to x of this guy here, this is always 0. Because the derivative of a constant, it's just 0. Okay? This guy here, it's different from this. This guy here, since the upper limit of integration here is a variable, it's something that change. Okay, it's something that changes through the over the domain. Okay, okay. So this is a function. For different x, you will have a different value. So this is a function. So this is a function of x, to be more precise. You get the derivative with respect to x, you should get a function in terms of x. For this is a definite integral. Upper and lower limits of integration are constants. So if you do this, if this exists, it's just a number. So you get the derivative of this is 0. Derivative of constant is 0. So you have to consider those things when saying that the integral reverses or undoes the the derivatives. Okay, so the integral undoes the derivative or the derivative undoes the integral. So you have to consider the conditions or those facts. Okay, so now we define what we call an indefinite integral. So the statement, this guy here, capital F of x equals integral of f of x dx, okay? This means that capital F prime of x equals small f of x. So notice in this particular symbol here, in this particular symbol, you don't see lower and upper limits of integration. So you remove them, okay? So you don't see that. You just have the integral sign and the integrand. Okay? Integral sign and the integrand. If you get that integral without looking at the without considering limits of integration, you will get a function. And this guy here, this expression here means that the derivative of capital F of x, that's equal to small f of x. And here, this is what we exactly mean when you do, okay, when you do derivatives of integrals. So this guy here, this is derivative with respect to x of f of x. Okay, and now we are saying that capital F of x, it's this symbol here. So derivative with respect to x, this is the integral of f of x dx. Okay? And according to this, if we get the derivative of this is just a small f of x. And now it is clear that the derivative undoes the integral. Okay? And in here, particularly this symbol here, okay, this is called the indefinite integral of f of x or of f. So just one main difference between indefinite and definite. The definite integral, it has lower and upper limits of integration. You have some number here and you have some number here. Okay? For the indefinite, you don't have that. You just have a function. Okay? Questions so far? But what does this mean? This means this guy here, integral of f of x dx, this means that this is an antiderivative of the function small f. Because, well, when you get the derivative of this, you will get small f of x. That's the definition of antiderivatives. Which means, for us, starting now, antiderivatives and indefinite integrals, they mean the same thing. They are interchangeable. Okay? So, capital F may be called as an antiderivative or an indefinite integral of f. Therefore, if we have the definite integral, okay, definite integral from a to b of f of x dx, this can be written as the indefinite integral of f of x dx, but you evaluate from x equals a to x equals b. Okay? So this guy here, this is your indefinite integral, but you evaluate it from x equals a to x equals b. Okay? And therefore, you've seen this before. If capital F is an antiderivative of f on the interval AB, then by the second fundamental theorem of calculus, and combining the notations above, this guy here and this guy here, you will end up with this expression. So as I've said, you've seen this expression here. Okay? Some remarks. So the expression integral f of x dx gives the general antiderivative of f. So meaning if I ask you to write this or if I ask you to evaluate this, there's always a plus c at the end. Remember the general antiderivative? You have a certain antiderivative and then you add an arbitrary constant c. Okay? So this guy here, this always gives general antiderivative. The indefinite integral, this is a family of functions. Why? Because again, this is the general antiderivative. Okay? You have a plus c. So whenever you change the value of that plus c, okay, you will have one member of the family. C equals 1, C equals 0, C equals 2, C equals 1 half, etc. Those are specific, okay? Those are specific antiderivatives, okay? Whereas if you put the plus C, you are calling all the members of the family. So this guy here, it's a family of functions. Whereas if you do the definite integral, okay, I already mentioned this earlier, the definite integral, this is a number. Okay, this is a number if it exists. So indefinite integral, you get a function. For the definite integral, you get a number. Okay? Now, differentiation and integration are inverse processes, just like what I mentioned earlier. So by FTOC number 1, if f is continuous and AB, then the derivative with respect to x of this integral here is equal to f of x for all x inside the open interval AB. What does this mean? The derivative of an integral. On the other hand, if capital F is an antiderivative of small f, then capital F prime of x equals f of x. And therefore, the integral of capital F of x or capital F prime of x dx, okay? And this is your integral of f of x dx. That's equal to capital F of x plus c. So what we are looking at, or what we should be looking at, is this guy here and this guy here. So this one is the integral of derivative. You get the derivative, you integrate it. So integral of the derivative. But take note, you see here, instead of just getting capital F of x, you have the plus c. Okay, you have the plus c. Questions so far? No questions? Now, let me present the the indefinite integrals. So these are some properties and also some indefinite integrals that you should remember. Okay? You have here the integral of c times f of x dx. This c here, it can go out of the integral sign so that you just have here c integral of f of x dx. Here, if you have a constant, okay, if you have a constant here, you integrate that constant with respect to x. You'll just have kx plus capital C. And in a more general way, or a more general scenario, if you have x to the n, okay, where n is not equal to -1. If you integrate this, you will have x raised to n plus 1 over n plus 1 plus capital C. If you have now 1 over x dx, you integrate 1 over x dx, this is ln of the absolute value of c. Take note of that absolute value. Okay? So take note of that absolute value. The integral of e to the x dx, this is e to the x plus c. Integral of a to the x dx, this is equal to a to the x over ln of a plus c, where of course a is greater than 0 and not equal to 1. So take note in here, the e here, it's the number which is approximately equal to 2.718. So it's a number, right? It's not a variable, it's a number. This is number satisfies what? Okay, so in here where e is such that ln of e equals 1. That's one property. Okay? There are other ways to define this number in terms of limit. Okay? But anyway, I hope you've seen those other definitions from your Cal 1. So we will not, I will not bring it out in this session. Now, integral of sine x dx, that's negative cosine x plus c. And integral of cosine x dx, that's sine x plus c. Here we have integral of secant squared x dx, that's tangent x plus c. And integral of cosecant squared x dx, that's equal to negative cotangent x plus c. We also have integral of secant x tangent x dx, that's secant x plus c. Integral of cosecant x cotangent x dx, that's negative cosecant x plus c. What else? Look at this. integral of 1 over 1 plus x squared dx. This is equal to tangent inverse of x plus c. And lastly, you have the integral of 1 over square root of 1 minus x squared dx. That's sine inverse of x plus c. So these 14 formulas, actually from 2 up to 14, okay, you have to remember them by heart. Okay? For the exams, we do not give formula sheets. So you have to remember these formulas by heart. If you remember the derivatives counterpart, then you should also remember the integral counterpart, these integrals here. So remember, it's just a reverse process. Okay? Questions? Okay, let's start with some problems in here. So we want to evaluate integral of sine x over cosine x squared dx. So in here, let us see. So you have the integral. What we can do here is to rewrite cosine x as cosine x times cosine x. Okay? So you have sine x divided by cosine x times cosine x dx. And then one of the cosine x, you join it with your sine x. Then you separate the other cosine x. So what I'm saying is you can rewrite this as sine x over cosine x times 1 over cosine x, and then you have the dx. Follow so far? And then sine x over cosine x, that's just tangent x, correct? And then 1 over cosine x, that's secant x. So we have integral of tangent x secant x dx. And from here, this is straightforward. This is just this guy here, secant x tangent x dx. In here, you just interchange these two guys, tangent x secant x dx. So they are the same. Which means that this guy here, it's secant x plus c. Okay? Questions? Okay, so listen very carefully. Why is this plus c important in this scenario? So remember, indefinite integral is a family of function. And this c here gives you the members of the family, all of them. If you simply write, for example, okay, you have integral sine x over cosine x squared dx. If you simply write after long calculation, you just have secant x. What does this mean? So say you box this as your final answer. What does this mean? It means that this is the member of the family with c equals 0. Correct? So look, this is just one of those answers. It's a family, and you just got one member of the family. Okay? So your next question could be, how many points will be deducted if you forgot to write the plus C? I'll tell you. I'll ask you this. How many points should you get? How many members of the family are there in here? There will be infinitely many. There are infinitely many possible C's, correct? So you have to give everyone. How many members or member uh, did you have in here? You just got one member. So knowing your limits at infinity, you have one member over infinitely many of them. Therefore, how many points you'll get? 1 over infinitely many of them, that's 0. Okay? So consider that. Okay? So in in face-to-face classes, that is the joke. Okay, that is the joke, of course. In face-to-face classes, I would see your reactions. Unfortunately, this is online, and I don't see your faces, whether you laughed or not, or you grin, whatever. But yeah, there's a joke in that. Okay. Of course, I will not give you 0 for not putting the plus C, but you will get deductions. Okay, you will get deductions. Okay. So there was a reaction here. We would get the whole question wrong if we don't add the plus C? That's the joke. That's what I was saying. Okay. Of course, you will get some deduction. Very, very minimal deduction. Okay. But you won't get totally 0. But I will give deduction. For example, 0.05 deduction. Okay. For example, the problem is 5 points, you will get 4.95. Okay. What is that? That's a reminder of you having some mistakes. Okay. Although the mistake won't have a big effect. In fact, the mistake, um, well, technically, it will only have little effect at this point of the discussion. At least you will remember, I didn't get a perfect score for that because I forgot the plus C. That's how important plus C. So I will put a very minimal deduction, okay? Just for you to, just just to remind you that you should have written that plus C. Okay? Later, I will explain further how important this plus C is. You will see a more mathematical explanation why this plus C is important. Okay? Questions? Let's see. Next problem here. Integral of 4t to the 7 minus 3 cosecant squared t dt. So if we follow our formulas here, this becomes 4t raised to 7 plus 1 divided by 7 plus 1. So for this, I am using this guy here. This guy here. I have x to the 7. So you have there 7 plus 1, 7 plus 1 in the denominator. So that's for this guy. And then minus 3. We integrate this cosecant squared t dt. We will get negative cotangent t. Okay? You'll get negative cotangent t. And then you have the plus the arbitrary constant here. So for this guy here, I am using this formula here. So this guy here, integral of cosecant squared x dx, that's negative cotangent x plus c. So if we simplify this, we will have 4t to the 8 over 8 plus 3 cotangent t plus the arbitrary constant c. Further simplification, we will have t to the 8 over 2 plus 3 cotangent t plus the arbitrary constant c. Okay? Questions? Okay. So you might ask, can you go directly from this up to this? Totally fine with me. You can skip this part, you can skip this part. Okay? So you can write immediately. Well, actually, from here, you can go to this part here. Meaning you can skip this part, these details here. T raised to 7 plus 1 over 7 plus 1. You can skip that part. Okay? And you won't get any deduction for that. Next problem here. So in here, we have a definite integral. So integral from 0 to 1 of this expression here. So 5z to the 4 plus 4z minus 4 over 1 plus z squared dz. Okay? So what do? We can look at the indefinite integral first. Okay? So at this point of the lecture or discussion, I'll be writing this. So I'll do the scratch part. You start with the indefinite integral of 5z to the 4 plus 4z minus 4 over 1 plus z squared dz. And if you do the integration, you'll get here 5z to the 5 divided by 5 plus 4z squared over 2 minus 4 arctangent of z plus c. Okay? So again, for these two guys here, we used the power rule for the integrals. For this guy here, remember arctangent. So for the last time, I'll show the set of formulas again. So I'm using this guy here. Integral of 1 over 1 plus x squared dx, that's tangent inverse of x plus c. Then for the other two guys, I used this here. Okay? So what now? We have the general antiderivative. Remember, when dealing with the definite integral, okay, when dealing with the definite integral, you can use any antiderivative. Okay? You can use any. So what we're going to do here, when we evaluate this, we'll just choose the antiderivative with c equals 0. Okay? So this guy here, this is now equal to 5z squared over 5. So, sorry, 5z to the 5 over 5. Let's just write it as 5z z to the 5 plus 4z squared over 2. Let's just write it as 2z squared. And of course, you have minus 4 arctangent of z. You close this, you can take c equals 0 as I have said. Okay, you can take z equals 0. And then you evaluate this from z equals 0 to z equals 1. Okay? Some of you may simply write 0 to 1. It's totally fine. Okay? 0 to 1 in here instead of z equals 0 and z equals 1. So to save up some ink or some energy. Okay? But what is this? This means that you start with z equals 1. So you replace all these guys here with z equals 1. So when z equals 1, you have 1 to the 5 plus 2 times 1 squared minus 4 tangent inverse of 1 quantity. Then minus z equals 0. So you have your 0 to the 5 plus 2, 0, 2 times 0 squared minus 4 tangent inverse of 0. Okay? So what happened here? This is actually your f of b minus f of a. Okay? So if you simplify this, you have 1 here. Here you have plus 2 times 1. So that's 1 plus 2. That's equal to 3. So that's equal to 3. Minus 4. I hope you still remember the value of tangent inverse 1. This is pi over 4. Okay? So you have this. And then minus, of course, you have your 0, 0. Tangent inverse of 0, that's also 0. So you just have minus 0 here. So if you try to simplify this, this is just 3 minus pi. So this is the final answer. Okay? Questions so far? Okay? Now, let me remind you, pi here, it's a number already. So you don't have to convert this. Besides, you won't be able to write the actual representation of pi. You will only use approximate value. If you're going to change that to pi, okay, to pi as 3.14, then they are not equal. 3.14, it's just the approximate value. Okay? Your pi is approximately equal to 3.14. Okay? But when you have these numbers, pi, square root of 2, e, and other numbers, you don't convert them to some decimal representation because you won't be able to do that. You don't also get approximate values for them. You don't do that. Okay? Um, what else do I want to mention? If you have fractions, retain that fraction. You don't convert them. Okay? For example, you have 1/3. Some students some students will write this 0.33. But this will never end. This is 0.333, etc. Or simply, you can write this as this guy, 0.33, and then put a bar on top of 33. This means that this 33 will never end. Okay? So to save you from harm, just write 1/3. Okay? Just write 1/3. Next problem here, we have to integrate. So definite integral from 0 to 1 of 5x plus x to the 5 minus 5 raised to x dx. So again, let's just put this here. Some students do this, so I'll just do this here. You have the integral of 5x plus x to the 5 minus 5 raised to x dx. So for 5x, that's just 5x squared over 2 plus for x to the 5, we'll have x to the 6 over 5. And then for 5 to the x, we will have 5 to the x over ln of 5. And then plus the arbitrary constant c. And therefore, if we go back to the original problem, we can have c equals 0 and then just write this part and then evaluate from 0 to 1. So we have 5x squared over 2 plus x to the 6. I just noticed here, this should be over 6. That should be over 6. And then, so you have here over 6 minus 5 to the x over ln of 5. You evaluate this from 0 to 1. So now I'm not going to write x equals 0, x equals 1. Let's just do that as from 0 to 1. Okay? So if we now start evaluating this, we now have, so at 1, so we'll just replace x with 1. We'll have here 5 halves plus 1 over 6 minus 5 to the 1. Okay, so I'll just write 5 over ln of 5. So that's for x equals 1, then minus quantity. We have here, well, 5 times 0 squared over 2. Let me write this as 0 immediately. Okay? So in here, I have 0 plus 0. And here, 5 to the 0. Take note, 5 to the 0, that's 1. It's not 0. So be careful. Okay? So 5 to the 0 here, it's 1. So let me replace this by 1. And I'll just put a note here. So note 5 to the 0, this is equal to 1. So if we simplify this, well, we can combine 5 halves plus 1 6. So 5 halves, this is also the same as 15 over 6. Then plus 1 over 6, then minus 5 over ln of 5. Then here you have minus minus, so this is plus 1 over ln of 5. So if we simplify this, we'll have 16 over 6, then minus 5 plus 1 over ln of 5, so that is minus 4 ln of 5. Then finally, we simplify this, 16 over 6, that's 8 over 3, then minus 4 ln of 5. So this is the final answer. Okay? Questions? Now, some applications of these indefinite integrals, definite integrals, antiderivatives. Okay? One of them is the following. Net change. Okay? So what is this? If f prime of x represents the rate of change of quantity y equals f of x with respect to the quantity x, then f of b minus f of a, this is the change of y when x changes from x equals a to x equals b. So when you discuss derivatives in your Cal 1, one of the interpretations of derivatives is rate of change. Okay? On the other hand, if you integrate that rate of change function, so if you integrate f prime of x dx from x equals a to x equals b, what you will get now is the change in y, okay, when x changes from x equals a to x equals b. So again, f prime of x, it's the rate of change of f of x. It's the rate. On the other hand, if you integrate that rate of change, okay, from a to b, what you will get is f of b minus f of a. So this is the change in the value of y. Okay? So you have this. By the second fundamental theorem of calculus, you have this expression. So this means the integral of a rate of change is the net change. It's the change of the quantity y. Okay? It's the change of the quantity y when the independent quantity changes from x equals a to x equals b. Some net changes here. Okay? So for example, if capital C of x is the cost of producing x units of a commodity, then the marginal cost, it's the derivative. Okay? So in here later, when we say marginal, it only means the derivative. Okay? So the marginal cost, it's the derivative. Therefore, if we integrate, okay, if we integrate from x sub 1 to x sub 2, the marginal cost function, it will give us this value, the net change of the cost. Okay, so this is the increase in cost when the production increased from x sub 1 units to x sub 2 units. Okay, questions? Another one here. If V of t is the volume of the water in the reservoir at time t, then its derivative V prime of t, this is the rate at which the water flows into or out of, okay, the reservoir at time t. So you have a tank, okay, you have a tank, and then you pour water into that tank, okay. The rate of change, okay, at which the water flows into will be the derivative. Okay, I mean the rate in which the water flows into that tank will be the derivative. Or you have a tank, it's full of water, and then you punch a hole on the tank so that water goes out. Then the rate of change, okay, or the rate at which the water flows out, okay, will be the derivative of the volume function. Therefore, again, as in before, if we integrate this, v prime of t dt from t1 up to t2, this will give us v of t2 minus v of t1. The initial volume, or the final volume minus the initial volume. That's the net change. That's the amount of water that went out or that is added into. Okay? So this guy here, it's the change in the amount of water in the reservoir between time t1 and time t2. Another one here, let S of t be the position of a particle moving along a straight line at time t. And remember, if you get the derivative of the position function, you will get your velocity. And of course, if you get the derivative of your velocity function, you will get the acceleration. Okay? Then we have the following. If you integrate your v of t, okay, from t1 up to t2, you will get s of t2 minus s of t1. This is the displacement of the particle after moving from time t1 to time t2. Okay? So for example, this is your straight line. Okay? Your particle started from here. This is your s of t1. So it moves this direction and then move back, then move again, then move back. Okay? And therefore, maybe the particle stopped here. So this is your S of T2. So if you calculate this guy here, you'll just have S of T2 minus S of T1. And that's exactly this distance here. So it's the displacement. Okay? Now, what if we have this? We get the absolute value of S of your V of t. The absolute value of your velocity function, it's the speed of the particle at time t. Okay? So regardless of the direction of the particle, the absolute value of the magnitude of the velocity function, it gives you the speed function. Okay? Therefore, if we try to integrate this speed function, so the integral of v of t dt from t1 to t2, this will give you the total distance traveled by the particle after moving from t1 to t2. Okay? So how is this? This is the straight line. Suppose this is the particle. This is at s of t1. Take note in here, there is no formula. Unlike in this guy here, we don't have the absolute value. So we immediately get this s of t2 minus s of t1. In here, you have to calculate it manually. You have the absolute value here. Okay? So how is this calculated? So in here, your particle started from this point, okay, from this point here. Say the particle moved on this direction and then went back, okay, went back there. Assume that this is on the straight line, but I'll just leave it here so we can see the difference. Okay, so from this point up to this point, you'll get the distance. So from this point until before the reversing of direction, before turning back, you have to calculate the distance traveled. And then, say the particle went back, okay? And then again, maybe decided to continue the journey. So, went forward again. So, the distance from this point up to this point, you will also calculate that. So, let's say that's your d sub 2. And then this is the last turn. And then after a while, the particle stopped in here. So you need to calculate this distance here up to this point, your d3. If you added all of this travel here, okay, this guy here, and then this guy here, that's the total distance traveled. Okay? That's the total distance traveled. Compared to this bullet, the displacement. The displacement, it's just from your initial point up to this terminal point. So if you calculated this distance here, okay, if you calculated this distance there, that's the displacement. So let me just write here. So this is the displacement. The displacement. So if this is your S of T sub 2, then this displacement here, this is your integral from T1 to T2 of V of T dt. Okay? Whereas, these red guys here, whereas if you calculate the integral from T1 to T2 of the absolute value of V of T dt, this is D1 plus D2 plus D3. Okay? Questions? Then, if a of t represents the acceleration of the particle at time t, then this integral from t1 to t2 of a of t dt, of course, this is equal to v of t2 minus v of t1. So this is just the change in velocity of the particle from t1 to t2. Okay? Questions? Let us consider this example. So a particle moves along a line so that its velocity at time t is given by this velocity function. Find the displacement of the particle. Find the distance traveled during the time period t between 1 and 6. Displacement, this is straightforward. So for number 1, displacement, this is just the integral from 1 up to 6 of v of t dt. So this function here, t squared minus 2t minus 8 dt. So from this point on, I'll not put the aside part. I will do that. I will combine that in the solution. So what I'm saying is I'll do the indefinite integral in here. So I will have some indefinite integral in here. And then I will evaluate it from t equals 1 until t equals 6. So in here, I will have t cubed over 3, then minus 2t squared over 2, and then we have plus 8t. And take note, in here, I'm no longer putting the plus c because I'm doing definite integral. Okay, so far? So let's just evaluate. This is now equal to what? 6 cubed over 3, quantity 6 cubed over 3, minus 6 squared. You have here 2 over 2. So the 2 and 2 there cancel each other. Plus 8 times 6. Then minus quantity 1 over 3 minus 1 squared plus 8 times 1. So we'll just have 8 there. So if we simplify this, 6 cubed over 3, that becomes 6 squared times 2. 32 times 2, that's 64. 6 squared, again, that's 36. Sorry, 6 squared, that's 36, and then times 2, that's 72. So this guy here, it's 72. And then plus 8 times 6, that's 48. Then minus quantity, you have here 1/3 minus 1 plus 8. So 1/3 minus 7, that's negative 20 over 3. Okay? So just a minor correction again. This guy here should be minus. So we have here minus. Here also will be minus. So let us see. So this guy here, this is minus. And therefore, what will happen to this? You have minus 1, minus 8, that's minus 9. So minus 9, that's also 27 or negative 27 over 3. So this guy here will be minus 26 over 3. So calculate that. And what will we get? 72 minus 36. That's negative. That's positive 36. So 36 minus 48. That's minus 12. Then here you have plus 26 over 3. So if we simplify this, we will have minus 36 plus 26 over 3. And this is negative 10 over 3. So this is the displacement. Okay? If all the evaluations here and simplification are correct, what does this mean? So if the particle, so you have this ground, if your particle is started from this point, after moving some time, the particle ended up here. Of course, the something to the right, this is our positive direction. So if this is the starting point of the particle, this is your 0. Okay, that's your 0. So from here, ended up at this particular point. Okay, so questions? That's for the displacement. What about the distance traveled? Oops, let's have here. For the for the distance traveled, we start with the absolute value. So here we have number 2. We start with the absolute value of v of t. So how do we calculate this? You have t squared minus 2t minus 8. You start by factoring this. Start by factoring this. So if you factor, this is t minus 4, t plus 2. Okay? And then you write table of signs. Okay? You write table of signs. So in here, if you equate this to 0, this means that t minus 4 equals 0 or t equals negative 2. So in here you have t equals 4 or, sorry, I already wrote t equals negative 2. But here you have t plus 2 equals 0 or t equals negative 2. This is negative time, so we don't care about that for now. But in here you have t equals 4. And your time period is from 1 up to 6. Okay? So what is that? Here you have the values of t. This is your t minus 4, t plus 4. And then if you multiply them, you'll get here the v of t. Okay? So t minus 4, t y plus 4. That's just plus 2. So t minus 4, t plus 2. So what about this? Say this is your 0. Okay? This is your 0 point. And then say this is your 1. This is 4. And then this is your 6. So if you look at this, on the interval 0 until 1, what is the value of t minus 4? When t equals 0, that's negative 4. When t equals 1, that's 1 minus 4, that's negative 3. So in between 0 and 1, the value of t minus 4 will be negative. The value of t plus 2 between 0 and 1, this is positive. So if you multiply these two guys here, you'll get this t minus 4 times t plus 2. So you multiply the signs, you will get negative number here. Okay? Between 1 and 4, between 1 and 4, you have t minus 4. What's the value of that? If your t belongs to 1 on the interval 1 to 4, or 1 and 4, 1 comma 4. If your t is between 1 and 4, exclusive of 1 and 4, the value of t minus 4 will also be negative. And for the t plus 2, it's still positive. So if you multiply these two signs here, you'll still get negative. At t equals 4, this is 0. This is some positive number here. At t equals 4, you will have 4 minus 4, that's 0. Which means that whatever number for the t plus 2, you'll still get 0 in here. Between t equals 4 and t equals 6, so your t is now greater than 4, t minus 4 will be positive, and this will also be positive. So if you multiply these two numbers, you will have positive in here. Okay? So what now? Your v of t, this is less than 0 for t between 1 and 4. So less than or equal. Equality occurs at t equals 4. Okay? And your v of t, this is greater than 0 for t greater than 4 but less than or equal to 6. Correct? So what is the absolute value of v of t? This is defined. So I think I will need a bigger space here. I'll write it lower portion here. The absolute value of v of t, this is defined. if your t belongs to the interval 1, comma 4, if your t belongs to the interval 1, comma 4, the value of the absolute value of t will be negative v of t. Remember, absolute value, if it is negative, you make it positive, correct? The absolute value of negative 2, that's positive 2. Or that's the same as negative of negative 2. Following? But on this interval, 1, comma 4, v of t is negative. So I have to put that negative to make it positive. Negative of some negative value here, it becomes positive. And if your t is between 4 and 6, your velocity, it's already positive. It's already positive. So you'll just have v of t in here. Okay? So I think you have to remember this absolute value definition. So absolute value of x, that's equal to x if x is greater than or equal to 0, and negative x if x is less than 0. So this is just the one we used in here. So what now? What now? If we want the distance traveled, so total distance traveled this is equal to the integral from 1 up to 6 of the absolute value of v of t dt. But this guy here, so this guy here, that's integral from 1 up to 4 absolute value of v of t dt plus the integral of 4 up to 6 absolute value of v of t dt. Remember that property of integral? You can chop the interval, but I'm chopping it at t equals 4. The reason is if we go back to this slide, that's where the sign changes for v of t. Okay? So what now? On the interval 1, comma 4, so in here, on the interval 1, comma 4, absolute value of v of t, it's negative v of t. So in here, this can now be replaced as the integral from 1 to 4 of negative v of t dt. So now we have removed that absolute value. Plus, on the interval 4, comma 6, absolute value of v of t, it's just v of t. So you'll just have v of t on this part. And now we're ready to use the value of v of t in here. We don't have the absolute values anymore. So if we do this, we have the integral from 1 up to 4 of quantity. You have negative here, so you multiply this expression here by negative 1. You will have minus t squared plus 2t plus 8 dt. then plus integral from 4 up to 6 of t squared minus 2t minus 8 dt. From here, do not even try to cancel these guys here. Because in here, look at the interval. It's 1 up to 4 in here. Whereas in here, it's 4 up to 6. And do not put them into a single integral, just like this. Because they are different function. Minus t squared plus 2t plus 8 for this interval. For this interval here, you have t squared minus 2t minus 8. So careful. Okay? So let's go to the next page. I'll just copy this. So from here, we evaluate. So now we have the usual evaluation. So we have minus t cubed over 3 plus 2t squared over 2 plus 8t. So this guy here, you evaluate from 1 up to 4 only. Then plus. Here you have again t cubed over 3 minus 2t squared over 2. And then minus 8t minus 8t. For this guy, you evaluate from 4 up to 6. So let's finish this. You have negative 4 cubed over 3 plus 4 squared plus 8 times 4 minus. You have negative 1 cubed over 3 plus 1 squared plus 8 times t, or 8 times 1. So this guy here, it's just for this part. Then for this guy, I hope I have enough space here, plus quantity. So take note, different signs. So in here, I have 6 cubed over 3 minus 2 times, oh, I just have minus 6 squared minus 8 times 6, then minus, at 4, you have 4 cubed over 3 minus 4 squared minus 8 times 4. So if we simplify this, 4 cubed, so 4 times 4, 16 times 4, that's minus 64. Now, minus 64 over 3 plus 16 plus 8 times 4, that's 32. Minus quantity, you have 1/3 or negative 1/3 plus 1 plus 8. Then plus. For this part, you have 72 minus 36 minus 48 minus the quantity 4 cubed over 3. That's 64 over 3 minus 16 minus 32. Let me put the parentheses also in here. So just simplify this. Okay, just simplify this and you should get a good answer. Okay. Questions for this problem? Is it positive 10 over 3? One of your classmates put positive 10 over 3. Just verify it if that's the final answer. Actually, let us try to do it. You have here what? Minus 64. So minus minus, that's plus. That's plus. So minus 64 plus 1 over 3. So that becomes minus 63 over 3. So you have here minus 21 plus 16 plus 32. So 16 plus 32, that's 48. And then here, 1 plus 8, that's 9, but there's a minus here, so minus 9. And then here, we got negative 12 in here before, so minus 12. And then for this, you will have minus 64 over 3 plus 48, because you have your minus minus, and then there's minus here. So plus 48. So if we simplify this, 48, so in here you have minus 21 minus 9, that's minus 30, minus 12, so that's minus 42, okay? And then minus 42 plus 48, that's plus 6. 6 plus 48, that's 54, minus 64 over 3. And 54 times 3, what's 54 times 3? That's 162 over 3 minus 64 over 3. So what is this? This is 98 over 3. Please check my arithmetic. Should be 98 over 3. Okay? Questions? So there's a question here. What if we took the negative out of b of t? Then you are not computing the total distance traveled. That's crucial there. The negative there is crucial. So you will really get big deductions. In fact, you might not get anything. Okay? Because if you do that, what you're calculating is the displacement of the particle, not the distance traveled. So totally different object. Okay? Other questions?